And welcome to the sixth section of our unit on geometric optics. In this section, we're going to begin looking at thin lenses. So first off, just as we had two types of spherical mirrors, we have two types of thin lenses. Each one has three different names, just because. A convex mirror, one form you might see, not drawn very well, is this, where it's symmetric on both sides. This is known as a biconvex. Another version of this lens that you might see is something like this. This would be more what would occur in a pair of glasses you get from an optometrist. In both cases, notice that it is narrower at the edges than at the center. So what I'm saying there is if I look at the edge versus the center, okay, it's bigger at the center than it is at the edge. Concave are just the opposite way around. So a biconcave lens might look something vaguely like this, but again, to within my ability to draw, that is not as symmetric as it should be. If I go to the optometrist and need a set of concave lenses to make my sight better, then I would get a pair that did something like this. And we see here that it is narrower at the center than at the edges. So for this unit, what we're going to focus on is ray diagrams. For those, I'm going to introduce some features that you need to be aware of. For the convex lens, we're going to consider the object to be on the left. Okay, so, and therefore, a real image will be on the right, a virtual image will be on the left. Okay, remember that unlike a mirror, the whole purpose of a lens is to pass light through it. Okay, mirrors are designed to reflect. Lenses are designed to refract. Therefore, a real image will be over here, and a virtual image will be over here. Okay. Think about if I want to use a lens to focus light onto the ground from the sun, maybe to pop a piece of popcorn, that spot that is formed would be a real image of the sun, and it is on the opposite side of the lens from the sun. Okay. Also, unlike a mirror, lenses have two focal points, and it's important to know which one is which. Okay. For the convex lens, f2 occurs on the object side, and f1 is going to occur on the image side. Now, you can memorize. I like a picture. It makes me happy. What I'm looking at is this half of the lens. And I see that as being Pac-Man's mouth. And if that's Pac-Man's mouth, that means the rest of Pac-Man is over here. And yes, I know he's more spherical than this. But that means that Pac-Man is trying to gobble up all the little pellets that are on this side, right? One of which sits at F1. Okay. This was the first side of the lens that the light, after coming from the object, would hit. So this is the first side of the lens, and if I make a Pac-Man out of it, it gobbles up F1. A Pac-Man out of the other side of the lens, the second side of the lens, would gobble up F2. Now, just to make things a little bit confusing, if we look at a concave lens, again we have two focal points, but they're on opposite sides of the lens from the convex. So again, if I think about this being my object side, ooh, there's a C in object. F1 is now on the object side, whereas before it was F2 on the object side. If I again look at the first side of the lens that the light would encounter as the mouth of a big old Pac-Man, I tried to make him more spherical this case. It's a very mean looking Pac-Man. See how that first side again gobbles up F1, which is why it has to be on the other side. Okay, So we're going to draw ray diagrams now. We're going to start by looking at the convex lens. There are 3 rays. They are different from the rays we had for mirrors, but the set for lenses are the set for lenses, and it's always the same 3 rays again. So first we're going to start off with an a object that is further from the center of the lens than twice the distance from the center lens to the focal point. So F2 is here. 2F2 would be maybe about there, just eyeballing it. You can see that DO is further away than that. Remember, all these distances, again, are measured from the center of the lens. Okay. Because we're thinking about a thin lens, okay, what is a thin lens? What is a thin lens is something that is thinner than it is tall, right? If I have something like this, that is thinner than it is tall. If I have something like this is not. This is a thinner lens than that one is. Okay, so for a thin lens, all of the change in direction actually occurs for ray diagrams at the center of the lens. In reality, what is happening is the light refracts a little bit at the first surface and a little bit more at the second surface, but it gives roughly the same effect for thin lenses as just considering everything happening at the center. Okay. So first ray has to hit the top of the object, travel parallel to the axis, and then it goes out through F1. The second one comes in, hits the top of the object, and F2 at the center of the lens turns and goes out parallel to our axis. So the black line and the blue line are parallel. And the last ray is shown in green. It goes from the top of the object through the center of the lens and just keeps going. Where these 3 rays combine right over here is where our image forms. Okay, so this is a real image. It is behind our lens. If I were to try to put a screen here, all I would do would be blocking light that gets to the lens. It would not affect where the image would form. Okay. So it's a real image. If we look, the object arrow points up, the image arrow points down, therefore this image is inverted. And if we compare the heights of the object arrow to the height of the image arrow, you can see that the object arrow is bigger. Therefore, this is a diminished image. The image is not as tall as the object. Okay, so what we're going to do now is do another convex lens ray diagram where what we're going to do is we're going to move the object in, and it's now going to be between F2 and 2F2, which is right there in this case. Okay. So same 3 rays. In across the top of the object, parallel to the axis at the center of the lens, we turn and we go out through F1. The second one hits the top of the object, goes through F2, hits the center of the lens, and then turns and goes out parallel. And the last one goes in and out through the center. And you can see that my rays didn't quite meet in a single point, but they're very close, so our image is going to be over there. Again, the image is behind the lens, so it is real. It's still inverted. The object arrow points up, whereas the image arrow goes from the axis downward. Right? And now if we compare the heights of the object and the image is by far bigger. Therefore, this is a magnified image, or enlarged, or bigger, or whatever word you want that means that here. Okay. And lastly, we are going to move the object again forward, so it's between the center of the lens and F2. And when we do that, what you see is it looks like it's within the lens. That's not the intent here. The reason I have an outline of the lens drawn here is just to remind you that it's a convex lens. In reality, the lens might be much narrower. Okay, so I'm not intending to put the object within the lens. It's just how it turned out for the drawing here. So, first ray from the object through F1. From the object parallel to the axis and then out through F1. The second one has to go through F2 and across the top of the object, and then turns and goes out parallel. And then the last one goes in and out through the center. Notice that all the rays coming in cross at the top of the object, but our 3 outgoing rays on the right-hand side of our lens in this case do not cross. Therefore, we do not get a real image, we get a virtual image. Okay, so this image is going to be virtual. Just like with mirrors, what I have to do to find my virtual image is figure out where do these 3 rays appear to come from, which means I back them up on the other side of the optic. So doing that, following the red outgoing ray back on the incoming side, if you will, and the blue one, and the green one lies along itself, so I can just use the same line. Our image is over here. It is a virtual image. Both arrows point up, therefore the image is upright. And we see the image arrow is taller than the object arrow, so it is magnified. Virtual, upright, and magnified. So lastly, we're going to work with the concave lens. This ray diagram is going to look very, very different. And the reason for that is because F1 and F2 have flipped sides. But it's the same 3 definitions for the rays again. So first off, we're going to put down our object. The red ray comes in across the top of the object, parallel to the axis. When it hits the center of the lens, the direction is determined by the point where the incoming ray hits the center of the lens and F1. So you can see I connect those 2 dots and it turns and goes out this way. Okay. This line back here is dotted because it's not real. It's not something that's actually there. It's known as a virtual ray. Okay. The blue one, well, the incoming ray for the blue one hits the top of the object and then has to hit F2. When that incoming ray hits the center, it turns and goes out parallel. So again, I've used a virtual ray to show that my incoming ray connects the top of the object and F2, but when I hit the center of the lens, I turn and I go out parallel. And then lastly, the green one is in and out on itself. That one's easy to draw. We again have a situation where the 3 outgoing rays don't cross. Therefore, I don't get a real image. This again has to be a virtual image. Okay. And I again have to back up the 3 outgoing rays. If I look at the red ray, its outgoing ray is here, and if I follow it back, I've already dotted that line in. The green one lies upon itself, so I don't need to worry about backing it up. The only one I have left to back up is the blue ray, the second one. That's here, and we see that the 3 outgoing rays appear to cross right in that location, so that's where our image is. Both rays point upwards, therefore the image is upright. And we see that the image arrow is much smaller than the object arrow. Therefore, our image is diminished. You can use smaller, whatever word there as well. So summarizing this, for a convex lens, I get 3 types of images. If I'm out past 2f with my object, then my image is real, inverted, and diminished. If the object is between 2f and f, then the image will be real, inverted, and enlarged. And finally, if the object is between the center of the lens and the focal point, then the image is virtual, upright, and enlarged. With concave lenses, I can only get one type of image out. It will always be virtual, upright, and diminished. In the next unit, we're going to do this exact same thing, but with calculations.